Okay, so we're gonna derive the double angled identities in trigonometry, and again, none of the derivations are necessary by the A-level syllabus. So let's get started. Firstly, what I'm gonna do is I'm gonna make a right angled triangle, and it's gonna be the same as the one I made in the previous video with a hypotenuse of 1. So if this is 1, as we mentioned and learned in the previous video, if this is 1, then this will be sine theta. And for now, let's not focus on the opposite. This is sine theta because we're going to suppose this angle is theta. I forgot to mention. If this angle is theta, then this is sine theta. And now what I'm going to do is I'm going to mirror this triangle. This is a right angle, this is theta, and this is 90 minus theta. So I'm going to mirror this triangle so that on the other side, it's basically both of the thetas are next to each other. And if this is theta and this is meant to be 1, then this will also be sine theta. So what I'm noticing here is that this is making a large triangle. And in this case, we can see that this whole length is 2 sine theta. So I can say that the length of this whole triangle on this end is 2 sine theta. And now what I'm going to do is, notice that if I add these angles for the larger triangle, this whole angle becomes 2 theta. So now this whole angle for this triangle is 2 theta, and this side is 2 sine theta. And this side is 1, and this side is 1, and this is 90 minus theta, and this is 90 minus theta. So by using the sine rule, I can derive the first double angle identity. So this is 2 theta, so I can write this as sine 2 theta. And I can write 2 sine theta in the denominator. And I can equate this to either one of these ratios because they're both the same. Both are 1 on one side and both are 90 minus theta. So this is 1. So I'm going to write 1 in the denominator. And this is 90 minus theta. So I can write this as sine of 90 minus theta. Now, what we learned was that if we have sine 90 minus theta, that is the same as cosine of theta. So what I'm going to do is I'm going to rewrite this. I'm going to rewrite this as sine of 2 theta over 2 sine theta. And since this is just 1, I'm going to ignore that. This is sine 90 minus theta, so I'm going to write cosine of theta instead. So now I have this ratio, and from this I can easily derive the first double angled identity, and that is that sine of 2 theta is equal to 2 sine theta cosine theta. So this is where your first identity comes from. It comes from a very basic derivation. It's not that complicated as it was in the previous video. So this is your first double angle identity. And now we're going to derive the second one, which is for cosine of 2 theta. So again, we know that this angle is 2 theta. We know this side is 2 sine theta. So as we know from the cosine rule, it says that the side opposite to the given angle is going to be a squared is equal to b squared. Wait, let me just label this. We are going to say that this side is A, this side is B, and this side is C. So what this basically means is we can use the cosine rule on this. So we use A, so we write 2 sine theta whole squared is equal to b squared plus c squared, which is 1 squared plus 1 squared. We'll write the whole thing, but 1 squared is just 1, of course. So we write 1 squared plus 1 squared, and then it's minus 2bc cosine of 2 theta. So minus 2 multiplied by 1 into 1, and then cosine of 2 theta, because the side opposite to 2 theta was 2 sine theta, so we wrote that here. So I can just write cosine of 2 theta. And now all we have to do is just simplify this expression. So 2 sine theta whole squared is equal to 4 sine squared theta. And on this side, 1 squared plus 1 squared is simply just 2. And minus 2 into 1 is just 2. So I can write this as minus 2 cosine of 2 theta. And for simplicity's sake, I'm going to take 2 common on all of these sides. So what I get is 2 sine squared theta is equal to 1 minus cosine of 2 theta. And now I can arrange this so that cosine of 2 theta is positive. And the final expression I'm going to get from this is that cosine of 2 theta is equal to 1 minus 2 sine squared theta. Okay, so from this identity that we basically derived, we can rearrange this in separate ways. So we know that cosine of 2 theta is equal to 1 minus 2 sine squared theta, which we just proved. And there's 2 more ways of writing this, so a total of 3 ways that can help you in your examinations. So firstly, we know that sine squared theta plus cosine squared theta is equal to 1. So in place of 1, I can write this, and I can subtract 2 sine squared theta from this. And I can just simplify this further. And what I'll get basically is I'll get cosine squared theta minus sine squared theta. So this is the first rendition of how you can write this. And another one for this is, instead of changing the 1, I can change the sine squared theta. So I can write 1 minus 2, and instead of sine squared theta, I can write 1 minus cosine squared theta. And if I expand this further, I get 1 minus 2 plus 2 cosine squared theta, which simplifies to 2 cosine squared theta minus 1, which I'll just write down now. 2 cosine squared theta minus 1. So this is basically 2 more ways of writing the same identity. It's better to know this because it helps you with faster calculations, but you can derive this if you really wanna in your exam, but I would suggest you get used to using these and have these memorized, because you can have situations where it's better to use these instead of the base identity, but they all mean the same thing. It's not different. So that's how we derived all the double angle identities. I hope this video helped, and thank you for watching.